Okay, today you are doing tangents and normals, finding the equations of tangents and normals to a curve. So the first thing that you need to be aware of is the gradient of the curve, of course, is f dashed x, but it's not only that, but it's the gradient of the tangent as well. The other thing you need to know is that a normal is something that's at 90 degrees to something else. So if, for example, we've got a curve that's like that, we've got a tangent that goes like that, even though it is a wobbly one, then the normal, this angle here between the tangent and the normal, is 90 degrees. So what does that mean? Well, what that means is, if you think back to your coordinate geometry, when perpendicular lines, the gradient, in this case of the tangent and the normal, because they're perpendicular, is -1. So we need to know that as well. The other thing we need to know is the point gradient form of a straight line. There it is there, y minus y1 equals mx minus x1. And the last thing is that parallel lines, well, we all know they don't touch, but they have the same gradient. Alright, so there's a couple of questions that look at that when you get to your questions in your book. Okay, so the question here says find the equation of the tangent to the curve y equals x squared plus 3x plus 2 at x equals 1. So we're going to be using y minus y1 equals mx minus x1. So there's a couple of things we need. We need to know a y value, and we need to know a gradient. So the y value we can get by just substituting x equals 1. So our y value, x equals 1, into those places there. And when we do that, we get that y equals 1 squared plus 3 times 1 plus 2, which hopefully comes out to be 6. So that's our y1 value. Alright, our gradient is the derivative, which is dy dx, and hopefully we bring the 2 down, so we've got 2x, and 3x becomes 3 when we differentiate. And of course the point we're looking at is x equals 1, so we shove that in. So gradient 2 times 1 plus 3, so that's 5. Alright, so we've got what we need. We've got a point which is 1, 6, and a gradient which is 5. So y minus y1 equals mx minus x1 minus 6 equals 5x minus 1. Expand, rearrange. Add 6. So the equation of the tangent is y equals 5x plus 1. So gradient of the normal, if we wanted that, not that we were asked, don't forget the gradient of the tangent times the gradient of the normal is -1. So the gradient of the normal then would be -1 over 5 dividing by both sides. And so the only difference between what we would do then, if we wanted the normal, we would put that there instead of this. Alright, and that's all there is to it. Okay, so have fun, and we'll be having a test on this stuff Friday of next week.